Hey guys, it's Miss Hudson here. Today's lesson is lesson 2-3, and our objective will be to test for equivalent ratios to decide whether the quantities are in a proportional relationship. So for this lesson today, I'm going to write down the formula you will need. It will be K equals Y over X. So make sure you begin to memorize this formula. Again, that letter K stands for unit rate, and it also can be called constant rate or constant rate of proportionality. I would like to go over your bell ringer for this day with you all because our math exam is coming up, and you will have several of these types of questions on that math exam. So we need to make sure that you all are understanding your bell ringer for today. All right. It says, what is the value of the expression? When you have problems like this, you must follow the order of operations, which we've learned as, please excuse my dear Aunt Sally. So the first thing we would need to do is to do what is in parentheses. So we would start by dividing out what we see inside the parentheses. So we would do negative 150 divided by 0.3. And when we do that, we end up getting negative 500. But don't forget to bring your 9 back over. So we'll rewrite our 9, and inside our parentheses, we now got negative 500. From this point, according to the order of operations, we should do exponents. Well, there aren't any, so we'll move to multiplication. We'll use the distributive property to multiply negative 9 times negative 500. Don't forget, negative times a negative is a positive, and when we evaluate this, we get 4,500, okay, which would be answer choice A. Okay, this is just a case question, guys, and it come from a case assessment that we took a couple years back, so I just wanted to give you an example of what types of problems you would see. This particular problem come from lesson 2-2 from the other day, so hopefully you would be able to answer this. It says, and again, this question is not in your textbook, okay? So if you're looking for this question, you will not find it in your textbook. You might just write this down on notebook paper. All right, it says it costs $36.75 for 3 tickets to visit the Science Center, okay? And then it costs $51 for 4 tickets to visit the zoo. So the first thing we would do here is find the unit rate. We need to figure out what it would cost us per 1 ticket. So let's start right here at this Science Center, and we'll take this $36.75 and we'll divide that by 3. And when you divide that out, remember your money normally goes in the numerator. So make sure you're punching in your money first, divided by 3, and you will get $12.25 for 1 ticket to the Science Center. All right, we'll do the same thing for the zoo. It costs $51 for 4 tickets. So let's divide 51 divided by 4. And when we do that, we'll see that it is $12.75 per 1 ticket for the zoo. All right, for the next question, how much would it cost for 12 students to go to the Science Center? Well, if it's $12.25 for 1 student, couldn't we take $12.25 and multiply that times 12 to see what it would cost for 12 of them to go? Well, if we do that times 12, we end up getting $147. That's what it would cost us to take 12 students to the Science Center. All right, how much would it cost us for 12 students to go to the zoo? Well, if it's $12.75 for 1 student, again, we could go times 12. And if we did our 12.75 times 12, we end up with $153 for 12 students to go to the zoo. Last question. If the group wants to spend no more than $150, who should they go with? Well, who's cheaper than $150? That would be the Science Center. Okay, now we are in your textbook. So make sure you are on the correct page. You should be on page 100, and this will be question number 4. It says to use the table below, do X and Y have a proportional relationship? Proportional relationship, guys, just means having equivalent ratios or equal fractions, okay? Now, this is where that formula K equals Y divide X comes in. If you get these backwards, y'all, it can really, really hurt you in the long run because on tests, there will be answer choices for those of you that do it backwards. So what we'll do here is we'll just divide all 4 of these values out in the form of Y over X. So beginning with the first one, it would be 5 over 2. The second one would be 7.5 over 3. Third one would be 12.5 over 5. And the last one, we would say 18 over 8. Okay? Now, grab that calculator and we will just divide these out. Remember typing your numerator in first. Okay? So we'll say 5 divide 2 and you'll end up with 2.5. Okay? 7.5 divided by 3, you will also end up with 2.5. For 12.5 divided by 5, also 2.5. And 18 divided 8 will give us 2.25. Okay, now we got to answer the question. It says, is the table proportional? Do they have a proportional relationship? Well, you have to pay attention, guys. If you'll look at our last value, 2.25, this is not the same as all of these others. Therefore, your answer would be no. And your reasoning here, because my ratios are not equivalent, this little guy was different. Everything has to match in order to have a proportional relationship. Okay? Each triangle is equilateral. Don't forget that an equilateral triangle means that each side is equal. Okay? Now, it says, is the relationship between the perimeter and the side length of the equilateral triangle proportional? Let's talk about this word perimeter. Make sure we understand what that means. Perimeter just means to add, okay? And we'll add all sides. Okay? All right, so looking at this smallest triangle here, if the side length of it is 1, wouldn't each side also be 1 if it's equilateral? Same thing for the medium size. If this bottom line here is a 2, then my other sides also have to be 2. Same thing for my third one here. If the base is 3, then the other sides are 3 because the question told us it is an equilateral. Okay? So to work this problem, we'll need to figure out which number goes on top in that numerator. And it states it right here. Is the relationship between the perimeter and the side length? So because of that word perimeter coming first here, I will set it up as perimeter over side length. So for this first small triangle here, we will add up all sides to get the perimeter. 1 plus 1 plus 1 is 3. So for this first one, I get 3 over 1, which is equivalent to 3. For the second one, 2 plus 2 plus 2 is 6. Okay, now 6 over 2 doesn't look like 3 over 1, but don't forget to simplify. 2 will go into 6 3 times. For the third one, 3 plus 3 plus 3 is 9, and 9 will go over 3. Okay, 3 will go into 9 also, again, 3 times. And some of you may be wondering, where am I getting my denominators? Well, I'm just taking the side length of each of my triangles, okay? That's where I'm getting those denominators. Well, our final answer, is each equilateral triangle proportional? If everything matches, then your answer will be yes. All right, this now is question number 6 in your textbook. It says, is the relationship between the number of tickets sold and the number of hours proportional? If so, how many tickets were sold in 8 hours? Okay, look at your table and notice there is not a number 8, right? So what I would like to do is I would like to start all the way at 1. So I'm going to rewrite my table. I'll have H for hours and T for tickets. Okay? Now, if you'll look, we don't really care how much tickets were sold in 3 hours. I would like to know how many tickets were sold in 1 hour. So to get this unit rate, I can just pick a point on my table. Any of these would have worked, but I always like to stick with the top. And remember, I'll type in as y divide x, okay? So your first column is your x's, your second column is your y's. So we will just divide 240 over 3. And that will give us the unit rate, how many tickets were sold in 1 hour. So 240 divided by 3, I get 80, okay? So this is right here is what's going to help me complete my table. So in 1 hour, I sold 80 tickets. How many tickets would I sell in 2 hours? Couldn't we just say 2 times 80? Sure, we'd get 160. 3 times 80, we would get 240. Okay, 4 times 80, we would get 320. 5 times 80, we would get 400. 6 times 80, we would get 480. And 7 times 80, we would get 560, and here comes our final answer. 8 times 80, and we would get 640. So the question asked us if the table is proportional, which it is because we noticed everything going up by 80, how many tickets were sold in 8 hours? Well, your answer would be right here in that table. In 8 hours, we sold 640 tickets. So the final answer to this question would be yes, it is proportional, and we sold 640 tickets in those 8 hours. All right, moving on to question 7. The amount of seed a landscaper uses and the area of lawn covered have a proportional relationship. Just complete the table. Okay, so this one told us it is proportional, so all we need to do is divide it out as y over x. Don't forget, make sure you're labeling your table. The first column you see will always be your x, and the second will be your y. So for the first one, we'll do 75 as our y divided by 3. And the last one, we'll do 100 over 4. And if you do both of these fractions in your calculator, 3 will go into 75 25 times. 4 will go into 100 25 times. So your unit rate for both boxes would be 25. Okay, maybe at this time, starting here with question 8, you could pause the video and try some of these on your own, okay? So at this time, I would like for you to pause your video and try a few of these on your own. And I will continue working from henceforward, so make sure you guys are trying on your own. Don't just depend on me to do all of them for you. All right, this again is question 8. Is the relationship between the number of slices of salami in a sandwich and the number of calories proportional? All right, here is your formula. K equals, which is your unit rate, y divided by x. So for our first one here, we would do 66 over 1, which is 66. For the second one, we would do 96 over 2. And when we divide that out, we better get 66. We did not. We got 48. And because I got 48, guys, I'm going to stop right there. There's no sense in wasting our time to keep going when we know the answer is no, it is not proportional because our ratios are not equivalent. Okay? For question 9, a wholesale club sells eggs by the dozen. Does the table show a proportional relationship between the number of dozen of eggs and the cost? Okay, for question 9, again, we will set up in the form of K equals Y over X. Remember, first column is your X, second column is your Y. So for the first one, we'll do 21 over 6. For the second one, we'll do 28 over 8. Third one, 35 over 10. And the last one would be 49 over 14. All right. And let's divide those out. Grab that calculator. 21 divided by 6, I got 3.5. Now that we need to make sure we get 3.5 on the rest of these. And if we do, it would be yes. Turns out that this one is a yes. Notice all of your ratios are equivalent. So this answer would be yes. All right, for question 10, does the table show a proportional relationship? If so, what is the value of y when x is 11? Well, first we need to determine if it is proportional, and we'll use our formula, K equals y over x. So the first one I see is 64. So we'll do 64 over 4. Then we can try 125 over 5. And let's just see what happens. So 64 divided by 4 is 16. Okay, that means this other one better be 16. So 125 divided by 5 is 25. Okay, I'm going to stop right there because I can see that this table is not proportional. Okay, because our ratios are not equivalent. Now, it says if it is proportional, what is the value of y when x is 11? Well, guys, we cannot tell them that, and the reason why is because our table is not proportional. Had it been proportional, we could have done the math to find that, but because it's not, it is impossible to tell them what y would be when x is 11. All right. For this next one here, for number 11, it says, does the table show a proportional relationship? Now, we're going to have some show work on this one, okay? Because we'll notice we have a bunch of mixed numbers. So what I like to do first is I will convert my mixed numbers to improper fractions, okay? So for my y value, and again, we'll set this up as K equals y over x. So for my y value, 1 2/3 turn into 5 over 3 as a improper fraction. And we'll divide that by 5, and we'll need to put an understood 1 under that 5. So that'll be our show work for the first one. Okay, for our second one, that one's easy. We'll just do 2 divide 6 for this one. Okay, for our third one here, we got another mixed number, so I will convert that using my backwards C. 3 times 2 is 6 plus 1. I got 7 over 3 divided by 7, and we'll need to make sure we put that understood 1 under there. And for the last one, let's do the same thing and use that backwards C. 3 times 2 is 6. Plus 2 is 8, so that would be 8 over 3 divided by 8. And we'll need to make sure we put that understood 1 under that 8. Whew, okay, now that we have our problems in the form that we can work with them, we will do a keep, change, flip to solve. Okay, so we'll keep 5/3, change to multiply, and we'll flip to be 1 over 5. So my final answer here, I get 5 over 15, which will simplify to 1/3 as my final. Okay? 2 divided by 6, well, that's divisible by 2. 2 will go into 2 one time. 2 will go into 6 3 times. So far, so good. For the third one, we'll do keep, change, flip. Keep that 7 over 3. Change your operation to multiplication and flip to get 1 over 7. For this one, I get 7 over 21. That will also simplify. 7 will go into 7 one time. 7 will go into 21 3. Okay, last one. Keep it, change it, flip it. All right. So we'll keep the 8 over 3, we'll change to multiplication, and we'll flip to get that reciprocal 1 over 8. I end up with 8 over 24, which again will reduce down to 1/3. So is the table proportional? Yes, it is. Everything matches at 1/3. But it says, if so, what is the value of y when x is 10? I told the students in class today a little thing that rhymes to help them memorize it. And my little saying is like this. When you're looking for y, you multiply. So what we'll do is we'll take our unit rate of 1/3. We'll take that 1/3 and we'll multiply it times that 10. And don't forget, we'll need to put that understood 1 under there. And when we multiply this, y'all, we end up getting 10 over 3. Now, we're in the 7th grade, and that's an improper fraction. We cannot leave it like that. So 3 will go into 10 3 times. 3 times 3 is 9. That's leaving me with 1 remainder, and my denominator never changes. So final answers would be yes, and the value of y would be 3 1/3. All right, for number 12, says the height of a building is proportional to the number of floors. The figures show the height of the building with 9 floors. Write the ratio of height of the building to the number of floors, then find unit rate. Okay. Well, some of you might be questioning which one goes in the numerator. How do I know how to set it up? Well, it states it right here. What is the ratio of the height of the building to the number of floors? So when I set this up, I will set this up as height over floors. My height is 135. My floors, it's stated up here in bold, 9. So we'll divide that by 9. And 135 divided by 9, you will end up with 15 feet per floor. Okay? How tall would the building be if it had 15 floors? Well, if one floor is 15 feet, couldn't we use multiplication to get our final answer? So grab that calculator, and 15 times 15 will get a final answer of 225. All right, do the two tables show the same proportional relationship? Guys, if you were to solve using your formula, k equals y divide x, for this first table here, you would end up with k equals 2.25. And for the second table, if you did your math correctly, k equals y divided x, you would get k is equal to 2.5 down here as well. So the answer would be yes. Both tables are proportional. I hope this helped out, guys. And if you need me, don't forget I am on my Google Meet from 2:15 to 3:15 every day.